Okay, this is my presentation on how I did the two problems I picked from the exam to do for the extra credit work. And I picked problem 14 and problem 15, and I'll show them how I did. So on the exam, this is what I tried doing. I wrote down the variables, position, velocity, time, and tried finding them. And I drew this little graph here to try to help me out. So it accelerates, constant speed, and then decelerates back down to zero. So this is what I tried doing. It was wrong, and I'm gonna try to show it again and how I did it this time. So same setup as before. I wrote down the variables, except the v initial for this time is 0, and the v final, velocity final, is 40 meters per second. And right here I wrote deceleration, which is 0.0625, which is what is given in the question, and total time traveled is 180 seconds. So how did I get that? Question A here asks, how long did it take for this part of the journey, for the first part of the journey? And that is how we find the time, the total time traveled. So x as the distance, there d is 3,600 meters, equals 1/2 v initial plus v final times the time. Now we're looking for the time. So plug everything in, 0 here, 40 meters per second here, and 3,600 there. Multiply, and we get 20 times t, which is 20t, over, and on the other side 3,600 meters per second, and the time, then you divide both sides by 20 to get the time by itself, and the total time traveled is 180 seconds traveled. The little s here stands for seconds. Okay, now moving on to B. B asked to find what was the acceleration during this time, and the acceleration, to get that, is the velocity v final times v initial plus a times t, one of the equations given in class. So v final, like we know, is 40 meters per second, v initial is 0, and the time, the t here, is 180 from the answer we got earlier. So multiply everything, you get 180 times a, and you divide both sides by 180, and I got 0.222 meters per second squared as the acceleration. Okay. Now to find the total distance traveled during this time, during the first part of the journey, is find the total distance traveled during the second part of the journey, which is this part of the graph right here. We multiply the velocity times the time, which was given right there, 40 seconds. So that's why I said this is the second part of the journey, because this takes 420 seconds, right? So that's just distance is velocity times time. That gives us 16,800 meters. To find the distance traveled during the third part of the journey, which is right here, to find this total distance, we do the v final squared, v initial squared, plus 2 times acceleration times distance. Now we're trying to find the total distance traveled, so we just plug everything and leave the d by itself. Square root of 0 is 0. Square root of 40 squared, not square root, 0 squared is 0, and 40 squared is 1600, minus 0.13d. Now I added 0.13d to both sides to move the d to the left side to get my final answer, and then I divided 0.13, divided it by both sides to get d by itself, and that gives us total distance traveled of 12,307.69 meters. Okay. Now, to get the total distance traveled on this graph, which is from here to here, all of this distance, we have to add every point of the journey into an equation, which is what I did on here, total distance from that graph, which is 3,000 as the first part of the journey, 3,600 plus 16,800 plus 12,307.69 equals, that gives us 32,707.69. Now I did the second part. This is question 15. I numbered it 2, but question 15 asks us, Mr. Chen tosses a 0.15 kilogram tennis ball straight upwards. So toss straight up, sorry. The ball passes the level of a balcony at a time 0.62 seconds after release, and again add 1.4. Come on, focus. At 1.4. Determine the height of the balcony above the release point. Neglect air resistance and show your work. So I tried doing it again on the test like this. I tried finding the difference in the time from the first point across to the second, and that gave us 0.52. That's the delta time, and I don't even know what I was doing here, so I'm not even going to bother. But again, wrote down the variables as before. Weight of the ball, T1 and T2. Now to get the delta time, I minus T2 minus T1, which is what I did on the test, to get 0.52 as the delta time. Now to get the average of both times, 0.52 divide 2, because those are two crossing points. Those are two points in which the ball crosses after the toss. That gives us 0.26 seconds, and the total height completed by the ball from the bottom from the bottom of the building to the balcony top. Now you add the first time T1, that will be 0.62 plus the average of that of the delta time, right? The difference of the delta, because that's the distance traveled. This is how long it took to cross from point A to point B, and this is the average of that. How fast is going in between those two, and from top to bottom. This is the average in between those 2 points. So 0.62 plus 0.2, that should say 0.26 seconds equals 0.88. That's the total distance traveled top to bottom. Now to find the velocity, traveled, which is the initial velocity when the ball was tossed, we don't know that, and we're using A here is the gravity, because the ball is falling using gravity. So that would be VI plus A times T. We already know what T is. T is 0.88 seconds, and VI and A is gravity minus 9.8. So VI, move it to the left hand side of the equation to get the answer. Multiply this, gives us the initial velocity of 8.624 meters per second. To find the height of the balcony, which is what the question asks for, we needed to find the velocity first, because that helps us find the height without going any further than we should. So delta of y is V initial times T1. That's very important, because that's the first point it crosses. So T1 plus 1/2 times times acceleration times 0.26, which is also v1. That's the first cross because it comes down. So the delta here, the delta of y, we multiply, we plug it in play. We multiply, we're trying to find the total distance traveled, which is dy. So multiply 8.62.4, 0.624 times 0.62 plus half times negative 9.8 times 0.62 squared. Square that, add all that up, that flips to a negative because of this negative sign over here. So it becomes 5.34688 minus 1.88636, which gives us 3.446052 meters. And if we round all of that up, that gives us 3.5 meters. And that's it.